So when we talk about average on data sets, we actually have a couple different ways to measure quote-unquote average, okay? So we call these measures of central tendency: mean, median, mode, and then mid-range. Mid-range is kind of like the lazy man's median, all right? So mean is the most common. When we talk about average, the mean is generally the first thing that comes to mind, okay? The mean is obtained by adding all the data set together, and then we divide by the number of data items, okay? The sum of the data divided by the number of data items. This is the Greek letter sigma. It means summation, okay? Summation. So when you see the Greek sigma, it means, hey, we're adding up a bunch of things. In this case, it means we're adding up all the data items and then dividing by the number of data items, okay? So we have a table here, shows the 10 youngest male singers in the United States that have a number one single. Find the mean age of the male singers at the time of their number one single. So Stevie Wonder had his first number one single at age 13. Donny Osmond also at 13. Michael Jackson at 14. Laurie London at 14, and so on, all the way down to Andy Gibbs at 19. Okay? So we want to find the average. So we add them all up. So we add up 13 and 13 and 14 and 14 and 16 and 16 and 17 and 18, and so on. What is the sum of all of those ages put together? What's the sum of all those ages, y'all? Say it. Someone else want to back them up? $159. Cool. So we add all of those up, and we get 159. Okay? How many data items do we have total? Say again? 10. Because they said, the top 10 youngest male singers. So we divide by 10. What's 159 divided by 10? 15.9. So the average age, or the mean age is 15.9. Okay, so almost 16 years of age. That's our most common measure of center. Now, it doesn't mean it's the one we always want to use, but we'll go through the others and we'll talk about when they're most useful. Okay? Now, sometimes we have a bunch of data. And it's not always practical to kind of just add everything up individually. Sometimes it's more useful to start with a frequency distribution table and then find the mean of the frequency distribution. It organizes it a little bit easier into some chunks for us. So when we have lots of data values that occur more than once, we use the frequency distribution, and then again we use this formula where we're finding the sum of the data values, but we're also multiplying the data values by their frequency. And then we divide by the total number of the frequency. So we looked at, you guys saw this chart on your homework yesterday, talking about students with their stress level. We had a bunch of students surveyed about their stress level, and they rated it from 0 to 10. And so on the left, we have their rating. On the right is the frequency. So 2 students rated their stress level at 0. God, it must be nice to be them. 1 student rated it a 1. 3 students rated it a 2. 12 is 13, and so on, all the way up to a stress level of 10. Okay? So adding up 0 and 0, 1, 2, 2, 2, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, gets a little excessive. So when we have it listed as a frequency distribution, what we can do is we can multiply the stress rating by each frequency to get a value for each row, and then we can add those all up. So 0 times 2 gives me 0. 1 times 1 gives me 1. 2 times 3 gives me 6. 3 times 12 gives me 36. And we want to continue doing that all the way down, and then we add those up to get our sum. So we're finding the sum of the data values times their frequency. And that's how we get that sum at the top, and it makes it a little bit faster to go through that process. All right, what's 4 times 16? And 5 times 18? 6 times 13? 7 times 31? 8 times 26? 9 times 15? So 135. And 10 times 14? 140. So now we want to add all of those up. So that's going to be, so the sum, let's see if I can draw a sigma. I'm really bad at drawing a sigma. That was awful. That was so bad. Okay? So the sum of all of the data values times their frequency gives me, should be 975. Okay? So we add up all the data values times their frequency. Then we got to figure out, well, what am I going to divide by? Well, I'm not going to divide by 10 because I pulled a lot more people. Okay? So if you don't know right off the bat how many people you polled, then you just have to add up your frequencies. So 2 plus 1 plus 3 plus 12 plus 16, 18, 13, 31, 26, 15, and 14. What is the sum of my frequencies? You know, it's okay if more than one person has a calculator up. Like, it's allowed. You're in a math class. It's actually highly encouraged. Some of the frequencies. So that's my value for n, 151. So 975 divided by 151 gives me a mean stress rating of what? 6.5? Was that exact or rounded? Okay, so we get an average stress rating of 6.5. Which when we look, we see, hey, most of the data values are clustered kind of in that range. So that makes sense. Most people are moderately to moderately high stress. Probably a little bit more this time of year. Actually, no, I think I find more of a split this time of year. Some people are just like, nope, I'm done. They have no stress. And some people are like, holy crap, I have 5 AP exams next week. Be interesting to compare beginning of the year to the end of the year. All right, another measure of center. We have the median. The median means the middle. Your driver's license, or we'll be getting one soon. So you know the median of the road is the middle part that divides the two sides, so that cars don't crash into each other. So median means middle. So the thing is, with median, this is the most important part. The data values have to be arranged in order from smallest to largest. They have to be in sequential order, otherwise you're not finding the actual middle value. Okay? Then, figuring out what the actual median is will vary a little bit whether or not we have an odd number or an even number of data values. If we have an odd number of data values, then it will be the middle number, okay? Because you can count from the outsides in and you end up with the middle number. Okay, there's one middle. But if we have an even value, we can split the data set evenly, which means we actually have 2 middle numbers. So then we just have to find the mean of those 2 middle numbers. Okay, add them together, divide by 2, and that will give us the median of the data set. Okay, if we have a bunch of data sets, especially if we're looking at a frequency distribution table like this one, having to try and count from both ends to figure out where the middle is a little excessive. Okay, and it has a lot of room for error. So we have this little formula that lets us figure out where the middle value is going to be. We take our number of data items, add 1, divide by 2. That tells us where the middle is, and so then we just have to count to that place. And that'll tell us where the median is, and that'll give us what the median value is. Okay? If the list is small, then it's not a big deal. We arrange it in order, and then we see what's in the middle. Okay? So is my first data set in order from least to greatest? No. So I need to rearrange it. What's the smallest value? 84. Followed by, and what number's in the middle? 90. We can see that pretty clearly. 90. So the median is 90. Okay. Now we have a larger data set. So we need to, again, get it in order. So lowest number is 7, followed by what? 17. And then? 15. Keep going. Wait, slow down just a little bit. Okay, what's after 34? 47. 59. 68. And then 74. Okay? Alright? So, a couple different ways we can do it. We can either count from the outside in to figure out where the middle is. So 7, 74, 13, 68, 15, 59, 25, 47. And here's my 2 middle numbers. If we want to use that position formula, we just take, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data sets, or 10 data items. So it gives me 5.5 would be the middle. So it's going to be between the 5th and 6th number. So that's going to give me my position. Since I have 2 data items in the middle, I need to find the mean of those 2. 28 plus 34 divided by 2. What's 28 plus 34? 62. 62. Divided by 2 gives me what? 31. So my median is 31. Just like mean, the median does not have to actually be a number in the data set. If we have an odd number of values, then it's definitely going to be a number in the data set. But if we have an even number of data values, then it's probably not going to be a number that's actually in the data set. Now, this has a lot of data values. Okay? So, we just want, luckily everything's already in order for us, so we just want to look for that position to see what our data value is going to be, what our median value is going to be. So we're looking at number of home runs by baseball teams in the National League in 2005. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 teams plus 1 divided by 2. What's 17 divided by 2? 8.5. So my position is 8.5. So we go 1, 2, 3, 4, 5, 6, 7, 8, 8.5, and 9, which means I'm going to have 2 data values. So just like that last one, we just want to find the mean of those 2 between the Astros and the Phillies. 167 plus 161. 328 divided by 2. So we have a median of 164 home runs. All right. Similar idea, but a little bit different when we're looking at a frequency distribution. This is the same frequency distribution from the first time we saw it with the stress rating. It's just turned sideways instead of vertical. So we have to look at our position formula again. Luckily, we already know the number of students because we solved it earlier. So, N is my frequency, the number of students surveyed. How many students were surveyed?
What's it say? Position over what?
Position formula. 115. 150, not 15, 51. 151 students were surveyed. Add 1 to that. Get 152. Divided by 2 is what? The 76th position is where our median is going to be. So then we just have to count through the frequency until we get to 76. So 2 plus 1 is what? 3 plus 3 is 6 plus 12 is 18 plus 16 . Say again? 34, okay. I'm not at 76 yet. What's 34 plus 18? 52. Still not at 76. What's 13?
65.
Still not at 76. Add 31. 96. So, this area right here contains items 66 through 96. Is the 76th position going to be between those numbers? So that is our median. 7 is the median.
What's that word on
Formula. So we figure out I have 151 students. We find the middle number is the 76th student. So we just count through until we pass the position we're looking for, and then that's going to be where our middle number is going to be located, is within that group of students that rated a 7. Now compare that to the mean we found earlier. What was the mean? What was the mean of this data set?
What was the what?
The mean of the data set.
How do you calculate the mean? One.
Guys, what was the mean?
Is the mean like
Say again. What was the mean? 6.5. Don't show up 20 minutes late to class and then ask what you missed. Okay, so are those values close? Yeah, they're pretty close. A lot of times, as long as there's not any what we call outlier data, if everything's pretty consistent within the data set, your measures of center are going to be pretty close together. Mean, median, okay? Because we're trying to look for what's typical. Now, different things will adjust and affect those values. And we'll go into more detail about those. But as long as our data is pretty consistent, then our measures of center should be close to each other. 6.5 and 7 are pretty close to each other. 6.5 was the mean. Now, talked about outlier data. So usually when we're looking at income, a lot of times we want to use the median rather than the mean. And we're going to find the median and the mean for this data set of income, and then we're going to compare them and see why we want to use median rather than mean in this type of situation. On that last data set, the values were pretty close. We had a really good idea of the average stress level, whether we used the mean or the median, because they gave us about the same thing. If we rounded 6.5 to a whole number, we'd end up with 7. Okay? So it was pretty close. We have 5 employees in the assembly section of a television manufacturing company that earn these wages respectively. You can tell this is an old book because, dear Lord, those are low numbers. Okay? The section manager has an annual salary of $95,000. Okay? So first we want to find the median salary. So we need to put those values in order. They're already in order. We need to find the middle number. So I've got 19.7 thousand. I've got 20.4 thousand, 21.5 thousand, 22.6 thousand, 23,000, and 95,000. Okay? So am I going to have a middle number or am I going to have 2 middle numbers? I've got 2 middle numbers, so I need to find the mean of the 2 middle numbers. 21.5 plus 22.6 divided by 2. 21.5 plus 22.6 divided by 2 gives me what? If you're finding the mean of 2 numbers. The mean. 32.8. Yeah, try that again. So, the median salary is $22,000. Okay, approximately $22,000. That's the median salary. So now we want to do the same thing, but we want to find the mean. So how do I find the mean again? What am I going to do with all of these data values to get the mean? Add them all up. So 19.7 plus 20.4 plus 21.5 plus 22.6 plus 23 plus 95. Should get $202,200. 29,000. These are all broken down into thousands. I rewrote 19,700 as 19.7 thousand, so it makes the adding easier. It's 29,000.
It's 23.
I don't know why I put 29. It's 23. You're right. What's that looking at? Much better. Okay. So when we add all those up, we get $202,200. Divided by how many people? 6 people. So based off of that, what is the mean salary? That's the mean. That's the median. What's wrong with having this as a mean value? Okay. How can I look at the mean and tell that that is definitely an outlier value? Compare the mean to the rest of the data set. It's bigger. Our mean salary is $33,000. Only one person makes above that amount. Everyone else makes $10,000 less, at least $10,000 less than the mean salary. Okay? So when you have outlier data, like often is the case with wages and salary, median gives you a better estimate. Even when we're talking about the average income for a family in a city or a state or the country. What is 1% of the world owns 90% of the wealth? I would say that's an outlier, right? So a median value is not going to be affected by the outlier nearly as much. A little bit, but not nearly as much as the median will be. Yeah.
So median would be like if you're trying to find average household income, and then median would be more like
Not necessarily. We would want to use median anytime that income or salary, anytime that there's an outlier in a data set. And we know there's often outliers when it comes to pay. Okay? Dr. Hoffman makes a lot more than I do. Okay? Which is fine. He has a lot more years of experience than me. Okay? Got a doctor's degree, one for that. Actually, I think Dr. Castleman. But so when that's involved, we know there's going to be outlier data. As far as a measure of center goes, as long as the data is relatively consistent and there aren't any outliers, mean is going to be a better measure because it takes into account all of the data set. Median just takes into account the middle part. Okay? But when we have outliers, the middle's not going to be affected by those outliers. It's not going to skew the data. Okay? So it just depends. Do we have outliers? No? Then let's use mean. Do we have outliers? Yes? Let's use median. Outliers are data values that are significantly further away from the bulk of the data set. Most of these salaries are between $20,000 and $30,000. And this one is almost 3 times that. Last measure of center we're going to look at is mode. Okay? Mode is the most. Usually we use mode with qualitative data when we're not dealing so much with numbers. Okay? So quantitative data would be I ask you a question and you give me back a number. How many glasses of water do you drink in a day? Okay? Or how many miles do you drive to school in a day? That's qualitative or quantitative data. It gives me a number. Qualitative data is usually something that gives you back an answer. What's your favorite color? What type of pets do you have? Those things don't give you number values, they give you words. Usually mode is used most with qualitative data. We can use it with quantitative, we can use it for whatever, but generally mean and median are going to be better. But when we're dealing with qualitative data, if I poll everyone what their favorite color is, how do I take the average of colors? You can't add colors together. Okay, so you have to look at what's the most common. Okay, now if we have a frequency distribution, mode is super easy because we just look for the biggest frequency. Okay, so here's my frequency. What's my largest frequency? 31, which means that my mode is going to be 7 because it has the highest frequency. So no, it's not 31. 31 is not the mode. 31 is just how many times the number 7 showed up, which happens to be the most number of times. So 7 would be my mode. Mode. Okay? So, find the mode of the data set. So we need to look to see how many times the numbers show up. Alright, 8 shows up 3 times. 6 shows up twice, so it's not that. 2 shows up once, 4 once, 10 once. So 8 is our mode. Okay? Mode is 8. Now, I want to talk about that sometimes there's not going to be a mode. If all the data sets appear, or all the data items appear the same number of times, there's no mode. But if I have 2 data items that show up the same number of times, then I have 2 modes. We call that bimodal. We could even possibly do trimodal. But anything beyond that, it just becomes it's not a useful piece of information, so then we just go and say there's no mode because it doesn't help us any.
If there's two, where are you supposed to like add them?
That's for median. Okay, so if we have two modes, we would just list them as my modes are this number and this number. But anything beyond that, really, it's not useful, so we just say there's no mode. Okay, and then mid-range, lazy man's median. The lazy man's median. Okay. This could be used if we have a massive data set and we don't want to figure out how many values we have or how many data items we have. But also, it's useful when we're dealing with data that changes constantly. There's not going to be one temperature during the day. The temperature is constantly changing all over any given area, all over the entire planet. It's constantly changing, okay? So in order to find the average temperature, how do you add up an infinite number of numbers that are constantly changing throughout the day? You can't. And so whenever meteorologists give an average temperature, what they're actually doing is finding the mid-range. They take the lowest temperature for that day, they take the highest temperature for that day, and they find the average of those two. Okay? And then they do that every day for a year, and then they find the average of those values. And then that's going to give you the mean temperature for any given place. Okay? So they find the mid-range on each and every day, and then they find the average among the mid-ranges. Okay? So mid-range is really useful when it's just not possible to add up all the data values or to figure out how many data values you have because they are so numerous. Okay? So mid-range is the lowest data value plus the highest data value and divided by 2. If I wanted to find the mid-range of all of these cities, I would find the highest temperature, I would find the lowest temperature, I'd add them together, that gives me
150.
thank you. Okay, 150.1 divided by 2.
75. Wait, so it's okay if like the lowest value has.
Yeah, it is still the lowest value. Yep. Okay, it just means it's going to pull the average just down lower. All right. So that is our mid-range. All right. It should be close to our median. It should be close to our mean as long as there's not many outliers in the data. Okay. Again, we could use it with this where there's a lot of disparity within the values. We don't have a ton of time left, so add them together, divide by 2. That gives you the highest and lowest, and there's your measure of the center. Okay?